Hi, I'm Brian Moore. I'm the program director here at Madison College in the HVAC department. I also teach some of the refrigeration classes in your program. So basically, what I want to do here today is show you a little bit about this virtual reality simulator. Now, I'm working in the 3D virtual reality um, realm. I'm got my goggles on. I got my hands, my little glove things. So the cool thing about this simulator, we also made it so you could do it in 2D, so you could do it at home without all the extra virtual reality requirements. So you could do it at home on your regular computer. So this should be a link that goes right in your Blackboard shell, and we should be able to allow you to practice some crucial skills for hooking up um, gauges to air conditioning units. So almost all air conditioning units are about the same way you hook up gauges. There's certain valves that we have to talk about on some certain equipment, but most rooftop units and split systems pretty much have straighter cores and allow you to hook directly up to them without having to worry about opening king valves and different access valves and things like that. So and that's a little different process. But the basic process that we're going to use, I'll be walking you through that. The other thing I want to walk through is a virtual reality world here. Is if you use your Joy-Cons joysticks, you can actually project yourself out there a little ways, and you can walk around your rooftop here. Okay, and then I could turn so I can face back at my roof. There's my unit back there I'm going to be working on, and I can walk back to my unit over there. So I could pretty much stand still and just turn using my Joy-Cons here. So let me get right in a good spot right about there, and then I can turn myself this way. All right, so here we are back in front of our system. Now, you'll learn when you're with the virtual reality gloves and everything, you'll have to learn how to push the buttons and everything in order to close your hand, make a fist, and different things like that, how to point, how to select things. So that takes a little bit of learning, but on your desktop, of course, you just go to that, hover over that item that you want to manipulate, and you select it and you click on it, and it should be able to, in the 2D world, should be able to make that do what you need it to do. All right, so what we need to do is basically go through um, what's the proper process for hooking up gauges to an air conditioning system. So typically we want to hook up our gauges at the lowest pressures possible. And typically, now sometimes you can't turn units off because of requirements of the facility and all that. So you just got to be as quick and try to create as little leak as possible when you're hooking up your gauges. Um, so one of the things you want to do is make sure your gauges are set up correctly. You want to make sure your valves are closed. So if I select my valve here, you can see now it's starting to open. And I want to put it back closed. And I want to make sure my other valve over here, which now I'm opening it, and I want to turn that guy back closed. Okay. And then you want to make sure that your hoses on the bottom are tight. All right, so you're gonna verify these are all kind of on tight and everything. It looks good. See, now this one is not on tight. It's actually loose. All right, and we could just accidentally leave this one loose and we could see what happens. Okay, so we'll see what happens when we leave that one loose. But now, the next thing we want to do is figure out, okay, we want to hook up at the lowest pressure possible. So we need to figure out, okay, when's it at the lowest pressure on the high side and when's it at the lowest pressure possible on the low side? Well, on the high side, if the unit's running, your pressures are going to be extremely high. That's why they have it red, and that's why they call it the high side. So it's going to be extremely high. So what happens when you shut these off, most of them will actually equalize across the high and low side. So the lowest pressure you're going to find on the high side of a system is when the system is off. So that's the first thing I'm going to want to do. I'm going to want to come over here, grab my high side, and we can see it turn. Then I can reach around and I can grab my high side hose. All right. And then I want to look for my high side piping. Okay. So the high side is the liquid side, which we know through our studies so far that the liquid side is usually the smaller pipe because you can carry so much refrigerant through a smaller pipe because it's denser, it's in a liquid form. So we're going to push this down here. Oh, look it, I got a leak because I left that loose. So you got to make sure your gauges are tight before you hook them up. All right, so there's a leak, there's refrigerant flying everywhere. And depending on what refrigerant it is, that could be very, very cold. So having gloves on is kind of crucial in hooking up this stuff. In case you have a leak like that where there's liquid refrigerant flying everywhere, that could be a very, very cold situation. You may not get that to go closed unless you're able to grab onto it with gloves. All right, so our high side is hooked up, and you can see my pressure changed, and it's saying, hey, for 200 psi, I must be at about 70 degrees outside. If this has been off for a while, if the temperature outside is 70 degrees, my pressure on this would be about 200 psi. All right, so now that would be like 410, 410A or refrigerant. All right, so now what I want to do is the lowest pressure for my low side is going to be when the system is on because it's going to pull it in, kind of suck. The compressor's going to suck it back, and it's going to be at a lower pressure. So we want to turn our system on. All right, so when we turn our system on, our high side pressure starts to climb really quick. All right, so you can see how that's going a lot higher in pressure. Now when we hook up our low side, come back here, try to grab hold of my low side gauges. Come on. Come on. It's a little clunky. It takes a little bit to get used to. And so now when it's low side pressure should be as low as possible. So I can hook that up. And now you can see my low side pressure is about 120 psi. Okay. Now before my gauges said 0 and 0s because I didn't have any refrigerant in there at all. You can bleed the refrigerant out just a little bit, or bleed any air out of there. Oh my goodness! Come on. I want to turn this because the high side, I know I got liquid refrigerant right at the gauges, so that's all bled out. So what might be inside this hose here is a little bit of air. Just trying to get, let's back up. See how that's frosting right up, okay? That's a little bit of leak. So when you bleed refrigerant out of a hose, you want to bleed just a little bit so that it's only the air really coming out of the hose, not the refrigerant. All right, so once you bleed it, and the reason we want to bleed is we want to get any air that could be in the hoses, we want to get that out of there because I don't want it in my system. All right, so now we're running, we could tell our pressures, we could do troubleshooting, all of this. So the next thing we want to do is everything's running great, we want to disconnect our system. So what is the proper way? So that was the proper way to connect the system, but what's the proper way to disconnect? Now this is where you got to pay attention to your steps. Really important because the EPA says you really need to do it a certain way in order to get rid of as much refrigerant as you can. So you can tell there's 280 psi of liquid refrigerant in here. That's a lot of refrigerant in that red hose. So I want to get as much of that out of there. This is 120 psi of gas. So not a lot of refrigerant, not many ounces at all. Maybe just like an ounce, not even an ounce, a tenth of an ounce, something like that. So you want to get as much out of there as possible. So how we do that is First of all, we have to isolate the high side hose from the system. So we have to take the high side off. When's the best time to take the high side off? When the system is off. So let's go ahead and turn this off. And we're going to watch the pressures change. Okay. All right. And when the high side pressure gets down to, hey, it's 70 in here, it's going to be, 200 PSI. You can see both gauges equalized out. They're both the same pressure. Okay. Now, I want to be able to take my high side off. Now, if this has just your Schrader cores, it should just quick connects on these would allow it to just take it off and there's no leaks or very little leak. If that has some kind of a valve system, you want to make sure it's valved properly before you do that. So I'm going to put this back here. All right, hook it up there, because you never lay your hoses on the ground, because as soon as you lay your hoses down, dirt and stuff gets inside them hoses and creates a contaminant that gets inside your next system you work on. So we don't want to do that. So now that I got a high side disconnected, you could put the cap on right now, or you could wait till you're all done, back onto this thing there. So let's go ahead and turn our system back on. Now you see now this 200 PSI has not changed. It stayed at the lowest pressure so far that your system would be in on the high side. But my low side, it changed back to 120. So now if I valve this properly, I could suck the high side liquid out of these and put it into my low side, because I got more pressure here than I do there. So how I do that is, you can meter. You want to meter because you don't want to slug your system with a lot of liquid. Again, there's liquid in this high side liquid line. You don't want to slug your compressor with a lot of liquid going back on your low side through the gas. So we want to we're going to open this. All right, we open that side. Now nothing's happening, because what that does is just opens a valve in the inside the manifold here that allows gas or the liquid to go through into the setup part of the manifold. And then if I turn this one open, that's to suck that liquid out of the center of the manifold and pull it down into the return. And it just automatically just went right down to 120. This may take just a little bit in real life to get that 200 PSI to come down to 120, because we want to meter this in slowly. Okay. Then once they're both at the lowest pressures possible, because if I turn the system off, they're both going to go back to 200. So I don't want to do that. So I want to close this guy, and I want to close this guy. Now everything inside the manifold is going to stay at 120. But these and the red line, since I have it disconnected here, that's all going to stay about 120 of gas now, because all the liquid we pulled over to the low side. So now it's just 120 PSI of gas. So now, if I were to turn the system off, this pressure would go way up. As you can see, 120 is better than 200 PSI. So I want to take my low side off like that, and put my hose back here like that, and then now my gauges are set at 120 PSI and everything. So now, if I had caps down here in the simulator, it doesn't have little caps you could put on there, I would definitely put the caps back on there. And in this case, I'd leave the system running because they need air conditioning. So that's pretty much the process. So if you guys have questions, definitely talk to your instructors. Otherwise, that's a typical process for hooking up and disconnecting gauges. Thank you, and hope this helps you guys, and practice a lot. Thanks.